Hey guys, so today what we're going to be talking about is how to find average atomic mass. This is what we did earlier today in class. So I'm going to give you the brief rundown. On your periodic table, the average atomic mass is usually the number that's listed somewhere near the element. So it's not the whole number, it's the one with the decimal number in it. So for instance, if we were going to look at neon today, which is what we did in class, its average atomic mass is 20.190. So what that means is that's the average of all of the isotopes of all of the neon that's found in the universe, okay? And we're going to go ahead and assign it a unit of atomic mass units. Now, if you watch the Khan Academy video, it does tell you that you can go back and forth between like AMUs to a molar mass unit to where this is just like a relative term that you can compare with other elements on the periodic table. But what we're going to do is figure out how did they come up with this number, all right? So I am totally going to make up random numbers here, but let's just say that neon is actually made up of 4 different isotopes. Let's say we have neon 18, neon 19, neon 20, and neon 21. Okay, let's say that those were the 4 isotopes of neon found in the universe. With those 4 isotopes of neon found in the universe, let's say that neon 18, there was only 1% of abundance. Okay, let's say that you had 2% of abundance of this one, and then let's say 0.05% of abundance for this particular isotope. And then for this one right here, let's say that one was the rest of it, so 96.5% of abundance. Okay. So if I ask you to find, what's the average mass of these isotopes? Well, without these percentages, like if we just cover that up, normally to find the average, you would just add those masses up, right? And then divide by 4. The problem is, though, this one is way more abundant in the universe, so it's going to affect the mass, the average mass. So what we're going to do is we're going to have to do an average that involves these percentages. So the formula to find average atomic mass, and this is called a weighted average, by the way, is we have to take into account those percents. So the formula would look like this. You would take the percent abundance of the isotope that we're talking about times the mass of the isotope. Okay. And so like if this is the first isotope, you would add that to the next one. So percent abundance times the mass of the next isotope. So isotope number 2. And we're going to add it to the next one. And so you get the idea, right? You take the percent abundance times the mass of the next isotope. And then on and on and on. However many isotopes that you have, you keep doing that, okay? So we would go ahead and set this up with this formula in mind. So this is the general formula to find your average atomic mass. So because of the fact that I don't want to have to mess with dividing by any number, though, I'm just going to turn these percentages back into decimal numbers. So this 1%, I'm going to let that be, I'm going to move the decimal place back to the left 2 places. So I'm going to let that be 0.01. This number, 2%, I'm going to let that be 0.02. That one, if I move the decimal back 2 places, it's 0.965. Then that one, I'm going to move the decimal place back 2 places, so it's 0.0005. Okay, just like that. So I'm going to take these numbers. So there's my percent abundance, and I'm going to start to plug it into this formula. So I'm going to take 0.01, so there's my percent abundance, times the mass of this isotope. So that's the first one. Plus, I'm going to take my percent abundance, 0.02, times the mass of this one, which is 19, plus, and you keep going. You're going to do that